Welcome back. In this video, we're going to talk about queue data structure concept. In JavaScript, a queue is a linear data structure that follows the first in, first out principle. It is similar to a queue that you might encounter in real life, such as a queue of people waiting to buy tickets for a movie. In a queue, the first person who joins the queue is the first one to leave. In JavaScript, a queue can be implemented using an array or linked list. As you can see in the example here, we create an empty array called queue. Then we add 3 elements to the back of the queue using the push method. Finally, we remove the first element from the front of the queue using the shift method. Another way to implement a queue in JavaScript is by using a linked list. A linked list is a data structure that consists of nodes, each of which contains a value and a reference to the next node in the list. Here is an example of how you can implement a queue using a linked list, for which I would like us to jump back on our terminal window. Now that we are on our terminal, let's open up our project. Let's create a new file called queue.js. Then we add our code here. What we are going to do, create a node structure class. The constructor will require a value to be passed as an argument, which we'll store in the local variable of the class. Then we'll have our next pointer, which we'll set as null by default. Moving forward, we'll create our queue class where constructor this first. So we'll keep track of our first element and the last element inside the queue. And we'll also need to keep track of the size of that queue. So we'll initialize it by 0. Then what we're going to do next is we need to enqueue and dequeue. So we'll need 2 methods which will help us add an element and remove an element. The addition of the element happens at the back of the queue. In a queue, the removal of an element happens from the front. Going forward, let's get our enqueue function in. For this data structure, the user will have to pass a value while enqueuing their data into the queue. So what we are going to do is let's create a new node constant, and inside it we'll pass our value. If it's an empty queue, what we'll do is in the first element we'll set the new node, and this is also going to be the last element. Else we are going to append the last element's pointer to the new node, and in the last value we are going to add the value of that new node. And whenever we enqueue, we should increment the size of the queue. Now let's look at our dequeue method. There is no need for us to have any input argument, since in a queue the dequeue method is going to remove the first element in the queue. With that notion, we'll check if it's an empty queue first. If that's the case, we'll return null. Otherwise, moving forward, to keep track of the node to be removed, we're going to set it in a const variable, which we get from the first node. And if this dot first is equal to this dot last, basically we're checking that if the queue has only one element, then this dot last is going to be null while dequeuing. And this dot first dot next. We'll set the first to the next of the first. And then we'll remove the node. And the remove node element that we have selected, that we are keeping track of, we'll set its next pointer to null. Then we decrement the size of the queue, and we simply return the value of the pointer that has been removed. Let's export it. Let's save this. Let's open our new tab. and open index.js. Let's import over here our queue. Now let's try to enqueue some data into our queue. Like this, we are going to initialize our queue constant with the queue class. And to enqueue, we are going to make use of the enqueue method. Let's add some data over here. Let's try to observe what's visible in our queue with a console log. Then save it. As you can see, the first node in our queue is having the value of 1, and the pointer is pointing to the next node in the queue. And the last node is holding the value 5 with the next pointer pointing towards a null. And the total size of our queue is 5. Let's try to remove our first element and then console log again to observe what happens to our queue. Let's save the file, run it. Now, as we can see, the size is 4. Now let's summarize what we did over here. In this example, we created a queue class that contains a node class as a nested class. The node class has a value property and a next property that refers to the next node in the list. The queue class has a first property that refers to the first node in the list, a class property that refers to the last node in the list, and a size property that keeps track of the number of nodes in the list. Then, the enqueue method adds a new node to the back of the queue by creating a new node instance and updating the next property of the last node to point to the new node. If the queue is empty, it sets the first and the last properties to the new node. Then we defined our dequeue method, which removes the first node from the front of the queue by setting the first property to the next node in the list and returning the value of the removed node. If the queue is empty, it returns null. So this was mostly it in this video. See you in the next one.